So this video is to go over chapter 10. The first thing I want to do, which is the most important step when you perform a hypothesis test, is to state the null and the alternative hypothesis and identify the claim. In this video, I will be using mainly Statcrunch. So this is only directed for students who will be using Statcrunch. And then there will be another video where I use the I-84. So let's begin of how to state the first step one, to state the null and the alternative hypothesis, HO and H1. More than 60% of Americans vote in presidential elections. You know, the null hypothesis is a statement of equality. It has to have the equal sign. Anything that has an equal, it has to be in HO. And anything that has greater than, less than, or not equal to has to be in H1. So more than 60%, you would agree with me that we have to have the more right here, and then 60% you can change it to a decimal, 0.60, and this is where the claim is. And as you know, the null hypothesis is a statement of equality, so I have to put the equal 0.60. Next one, the mean starting salary for San Jose State University is at least 100,000 per year. Okay, at least, guys. At least means greater than or equal to. Greater than or equal to. To show you this simple, it will be this one. Great. So it does have the equal sign. Greater than or equals to. It does have the equal sign. And you know the equal sign, anything that has an equal sign has to be in HO. So we should have it right here. So let me just copy it and paste it. It should be right here. 100,000. Now my question to you, what is the complement of a greater than or equal to? It will be a less than, the total opposite. So that should be a less than. But your book uses the following. You have to have only an equal sign in the null hypothesis. So what you do after you do all of this, you just erase this and put the equal now. But where is the claim this time? The claim happened to be in HO. Most of the time, the claim will turn out to be in H1, but I just intentionally put some examples to show you that the claim could fall in the null hypothesis. So if you have at least, then the complement to it that goes to the alternative hypothesis is less than. And if you have at most, then the complement of it that goes to the alternative hypothesis will be greater than. Okay, see, 20%, 29% of high school seniors get drugs. So it's exactly 29%. So that's an equal, 0.29. And what would be the alternative hypothesis? Not equal. Equal, not equal. And let me just get the simple, 0.29. And again, where is the claim this time? The claim happened to be in HO. Next one, fewer than 5%. This is a proportion. Anything that has to do with percent, guys, is a proportion. It's not a mean. So you have to use the simple P for probability, percent, proportion. Fewer means less than. And you know less than has to be in the alternative hypothesis. And that will be an equal. And the claim again is in H1. So what goes in the alternative hypothesis? These are the signs that go into the alternative: less than, greater than, or the not equal. Let me just get it. These are for the alternative hypothesis. What goes in the null? The equal sign only. The mean number of cars a person owns in her life is more than 10. So more than 10, guys, will be greater than right here. and that's the claim, and that will be equal. More than half American. More than half of Americans means more than 50%. So that's a percent. So this more than 50%, 0.50. That's the claim. And then P here will be what? Equals 0.50. So it's very easy to state the null. It's always the equal. European have mean paid vacation each year for at most 6 weeks. Okay, at most, guys, means less than or equal. Let me just show you this simple. Oops, I put it right there. Let me just put it right here. Simple, at most. Okay, this is at most. So this is less than or equal, so that should be in the null hypothesis. But what is the complement of at most? The opposite, the alternative, will be greater than. But since you're not allowed to put less than or equal in the null hypothesis, you have to put only the equal sign. You just put equal there. Equal 6 weeks, which is the claim. And then we agree that the complement of at most is greater than, and we put 6 weeks. The chance of developing breast cancer is 70%. So P equals 0.07. And again, I intentionally put some questions where the claim turned out to be in HO, but it's not the case in your book. Most of the claims will turn out to be in H1. Equal, not equal. And the last one, private universities mean tuition cost is more than, right here, 20,000. That's the claim. And that will be what? Equal 20,000. Okay, so this is how you state the null and the alternative. Now we're gonna do some actual problems where I show you how to perform the 5 steps of hypothesis testing using Statcrunch. Okay, let's read this one. This testing the proportion, section 10.2. A statistics instructor believes that fewer than 20% of Evergreen Valley College students attended the opening night midnight showing of the latest Harry Potter movie. So what is the claim? They're claiming that less than 20%. So that's what I did right here, guys. P is less than 20%. That's the claim. And then as we talked earlier, it's always an equal sign in the null hypothesis. Now, what do you need to run a hypothesis test for the proportion? You need how many in the sample, how many successes, and what's the level of significance. She surveys 252, so N is 252, and finds that 45 attended the midnight showing, so X is 45. Test the belief using a 5% level of significance. Why do we need the level of significance? Because we need to compare it with the p-value. If the p-value is less than alpha, we reject the null hypothesis, and if the p-value is more than alpha, we fail to reject the null hypothesis. So let me show you guys how to use Statcrunch right here. So I'm gonna bring Statcrunch. You go to stat. This is a proportion test. So you go to proportion. We're doing only one sample with summary. I don't have the actual data. Oh, I choose 2 samples by mistake. Stat, proportion stat. For this section, guys, it's a proportion, one sample with summary. All right. And let's show you. Number of successes, 45, I believe. Number of observation, 252. So X comes first, and then you put N. Let me just make sure. 252 and 45. Yes, that's correct. Okay, hypothesis testing. We're testing against 20%. So just put the 20, and we need to choose the alternative sign. HA means H1, the alternative sign, which is what we said, greater than. Okay, and now if you wanna, you can do a p-value plot and see what's gonna happen, guys. Compute, Let me show you, move this a little bit and show you. Uh, this is the test statistic Z, which is negative 0.85. That's the second step. And this is the p-value, which is 0. Let me see what we did here. Oh, we're testing for less. I made a mistake, so I need to change this one. I'm going to go to option, edit, and I put greater than, we're doing less than, sorry. And now I hit compute, and here you go, guys. Negative 0.85 is the test statistic. That's step number 2. The p-value, which is the most important part, just of this problem, which is 0.1975. So that's how you use a Statcrunch. And look, this is HO and this is H1. And the p-value is an area here. When you have a less than, the p-value is an area to the left of the z-score right there. So let me show it to you. You're going to see the p-value. See, this is the negative 0.85 and this is the p-value. You can find, the p-value using the normal calculator. Also, you find the area to the left of this z-score. But Statcrunch can do it when you run this test. So let's go back. Negative 0.85 is the test statistic. This is the p-value. We're going to compare it with alpha, which is 5%. And you agree with me that 0.1975 is bigger than 5%. If it is bigger, you fail to reject the null hypothesis. If it's not bigger, you reject the null hypothesis. So fail to reject the null hypothesis. Now the conclusion, guys. Let me show you how you write the conclusion. This is very important step. The conclusion for a reader, someone who doesn't know statistics. You test this belief. What do you think of this belief that you just tested? If you fail to reject HO, you start with there is not enough evidence. And if you reject HO, you say there is enough evidence. So since we fail to reject HO, you say there is not enough evidence at the 5% level of significance. 2, now, when you do your homework online, the book is going to ask you to select between the word support and the word reject. When the claim, guys, is in H1, you always use the word support. So you say, there is not enough evidence at the 5% level of significance to support the claim that I didn't write the whole thing, but you need to write the whole thing, that it's already there. Just copy and paste that fewer than 20% of Evergreen Valley College students attended the opening night midnight showing of the latest Harry Potter movie, and that concludes the problem. Let's say, guys, you ended up rejecting HO. Let's say this was a small number and it was less than alpha. What do you say? You say there is enough evidence at the 5% level of significance to support the claim. Okay? Let's go to the next one. Previously, an organization reported that teenagers spent 4.5 hours per week on average on the phone. The organization thinks that currently the mean is higher. Higher than what, guys? Higher than 4.5. So that's the claim. So look what I put here. Mean is greater than 4.5. That's the claim. And it's an equality statement in HO, so you always put equal there. 15 randomly chosen teenagers were asked. So N is 15. So this is a test for the mean, not the proportions. That's section 10.3. 15 randomly chosen teenagers were asked how many hours per week they spend on the phone. The sample mean was 4.75. Now, guys, here I'm giving you population standard deviation, which is not a common case, but I thought, just to introduce you to this. If you see a question where he gives you the population standard deviation, not the sample standard deviation, then you have to deal with it in a different way. Assume, look what it says here, assume that population standard deviation is 2. So it's not S, it's sigma. You see what I put? Sigma here. Conduct a test using a 5% level of significance. In order to test the mean, you need the size of the sample, you need the sample mean, and you need the standard deviation, whether it is sigma or S. In the most common case, it is S, but I thought it just to introduce this one, guys, in case if you see any questions where the population standard deviation is given, this is how you deal with it. So let's do this one and show. So when I use Statcrunch, because sigma is given instead of S, we use a Z stats. We're gonna be using Z stats. Okay, so let's see. Let's go there. So 15, 4.75, 2. Okay, let me close this one. You go to stats. You see Z stats, not T. Most of the time it is T, but for this particular question is Z. One sample with summary. Sample mean was what? 15. No, sample mean was, let's see. Let me go back. 4.75, 15, and 2. So 4.75. Standard deviation was 2. Population standard deviation. Sample size is 15. And we're testing against 4.5. And we want to test if the mean is higher than 4.5. This is the claim right here. Okay, if you want to do a p-value plot, we can do that. And hit compute. And let me show you. This is all what we need, guys. We need Z and we need the p-value. 4841 and the p-value is 3141. And you want the p-value is an area, since this is a right tail test, greater than the p-value is an area to the right of Z 40.48. Let me show it to you. You can see it. This is 0.48 and this is the p-value. So we're done with the Statcrunch here. I'm just gonna go back. So let me just okay, that we don't need here. So we got the Z, which is 0.48. The p-value is 0.3141. You guys agree with me that 31% is bigger than 5%, so we fail to reject HO. And if you fail to reject HO, you always start with there is not enough evidence at the 5% level of significance. 2, where is the claim? The claim is in H1, so you use the word support the claim that the mean time teenagers spent on the phone is more than 4.5 hours per week. I'm gonna go to the next question. All right. This is really the common case, in this chapter. A particular brand of tire claimed that its deluxe tire averages more than 40,000 miles before it needs to be replaced. So they claim that the average lifetime of the tire is more than 40,000. So I wrote the null and the alternative. You can see greater than 40,000, and this is always equal. And the claim is right there. A survey of owners of that tire design is conducted. From the 28 tires surveyed, so N is 28, the mean lifespan was 42,500. So X bar, guys, is 42,500 with a standard deviation of 3,800. He's referring to the sample. So it is S, and this is really the common case, guys. He didn't say population standard deviation like in the previous exercise. Use alpha equal 5%. Can you support the claim? So this is, since he gives us the sample standard deviation, it's going to be a t-stat, t-distribution test. And let me show you how we can do that using Statcrunch. So just go to Statcrunch. You go to stat. You see where it says t-stat? This is the common feature, guys, you're going to be using in this chapter. One sample with summary. I don't have data. And the sample mean is what? 40,500. Let me just check. 42,500. The sample standard deviation was 3,800. Sample size was 28. And we are testing against 40,000. So just put 40,000 here. You see, equal sign is fixed here. You cannot change it because that's how you state the null hypothesis. And we need to check if it is bigger. This is called the right tail test bigger. And you want to do a p-value plot, we can do that. Hit compute. And let me move this. Okay. This is the test statistic. It's big, 3.481. And look at the p-value, how small it is. So if I show you the p-value, you're barely going to see anything on the graph because it's very small right here. See? That's the area to the right of this. So 3.481 and p-value is 0.0009. That's what we need. All right. Let me write this here. T 3.481. And the p-value, if you use your calculator, it's going to show you this number, but the p-value here, 0.0009, which is, of course, less than alpha. It's a very small number. So what do we do? Reject the null hypothesis. And if you reject the null hypothesis now, you don't say there is not enough evidence. You say there is enough evidence at the 5% level of significance. 2, since the claim, guys, is in H1, you use the word support, period. There is enough evidence at the 5% level of significance to support the claim that, and you need to write the rest of the claim. I didn't write it down just to save time, that its deluxe tire averages more than 40,000 miles before it needs to be replaced. Next question. The mean number of sick days an employee takes per year is believed to be about 10. Members of a personnel department do not believe this figure. They randomly survey 12 employees, and these are the number of sick days they took in the past year are as follows. Should the personnel team believe that the mean number is not 10? So they're claiming that it is not 10, and this is how I stated the null and the alternative, guys. Not 10, not equal to 10, and equal to 10, and this is the claim. Use alpha equal 5%, assume that the population is normally distributed. The first thing, guys, you want to do is you're going to put that data in Statcrunch, and this is going to be data, not summary anymore, which I already done, and we're going to test against the number 10. So let me show you how to perform this one. I already put him in variable 3 because my screen only can see variable 3 here, the one I'm recording. So you can put him in variable 1, no problem. Stat. It's T-stat, guys. We only use the Z-stat if it gives us population standard deviation, which is a very uncommon case, guys. So it's going to be mostly T-stat for section 10.3 mainly, and proportion stat for 10.2. Just be aware of this. So T-stat, one sample, but with data this time. I have the data, and I put it in variable 3, and we're testing against 10. And this is not equal. Make sure you choose not equal. And if you want to draw the p-value, guys, you can do that. So let me just show you here. All right. Hypothesis testing. And let's hit compute. And look, guys. T is negative 1.729, 3 decimal places. And p-value is 0.1118. Degrees of freedom, guys, means sample size minus 1. 12 minus 1 means 11. This is the mean. If you add them up and divide by 12, you get this mean. So it gives you lots of stuff here. But all I care about the test statistic T0 and the p-value. And I already actually wrote them down in there. So let me take you back right here. And do you guys agree that this is bigger than alpha? If it is bigger than alpha, which is 5%, we fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you say there is not enough evidence at the 5% level of significance to support the claim. Because the claim happened to be in H1, you use the word support the claim that the mean number of sick days an employee takes per year is not 10. That is the conclusion of this question. Okay, next question. Your statistics instructor claims that more than 60% of the students who take his elementary statistics class go through life feeling more enriched. For some reason that he can't quite figure out, most people don't believe him. You decide to check this out on your own. You randomly survey 96, so that's N, guys, of his past elementary stat students and find 51% feel more enriched after they take the course. So N is 96 and X is 51. What do you think? Would you support the claim? So this is how you state the claim, guys. P is greater than 60%. That's the claim by the instructor. And you know it should be the equal sign here. And what is this going to be? A proportion stat. So I'm going to take you and show you how to perform uh, the test. Let's close this one. So we go to stat, proportion stat, one sample with summary. Let's bring this down a little bit. 51 is the number of successes. I think 96 was the sample size, and we're testing against which percentage, 60%, correct? And we need greater than, guys. There's a p-value plot. Compute. Let me show you here. So z is negative 1.38, usually two decimal places for z, and p-value is 0.19154. Wow, that's a huge. So let's write it down. Negative 1.38 and p-value equals 0.9651. And he didn't give us alpha. We will use 5% since he didn't give us alpha. Let me just so 0.6. Let me just make sure we got the right numbers. Yeah, 9651. Yep. Okay. Looks good. And compute. Look at the p-value, guys. How big? It's huge. Once you shade too much, that means you're not gonna reject, the null hypothesis. Because if p-value is less than alpha, we reject the null hypothesis. So I forgot what I put there. 9154. Of course, this is bigger than any alpha. So we fail to reject HO. And what's the conclusion? There is not enough evidence at the 5% level of significance to support the claim by the instructor. And then write it down that more than 60% of the students who take his elementary statistics class go through life feeling more enriched. One more. A poll done for Newsweek found that at least 6% of Americans have seen or sensed the presence of an angel. You doubt that the percent is really that high. You conduct your own survey. Out of 152 American survey, only 7 had seen or sensed the presence of an angel. As a result of your survey, can you conclude that the Newsweek poll was not correct? Okay, let's do that. Now, what is at least, guys? At least means greater. At least means greater or equal, greater than or equal. So it has the equal sign, which is greater than or equal, like this. Or let me show you the simple right there. Let me insert it. I want you to see that. That's okay. What would be the complement to it? Complement, the opposite. It will be this. So here's since at least has an equal sign in it, then this is going to be the null hypothesis. And because the null hypothesis can take the equal sign, so this is how it's going to look like. P equals 0.06 and H1 P is less than 0.06. Now, it's you who is making the claim. Can you conclude that the Newsweek poll was not correct? This is their poll right here. That's what they say. And we think this is not correct, so this is us right here. This is our claim. So N is 152 and 7 is X, the number of successes. Okay, let's check this one. We need to close that. Stat, proportion stat, one sample, guys, with summary always. Number of successes is 152. 7, we're testing against 0.06, and we think it is less than that. And p-value, if you like, you can graph it, compute. Oh, number of successes, that's the 7, sorry. Number of observation is the sample size. The first one is X, and the second one, I mixed up the two. Let me double check 152. Yes, 152 and 7, yeah. And finally, hit compute. Let me raise it so you can see compute, guys. And Z is negative 0.72, and p-value, look, it's a huge. You want to see it? It's going to be lots of shading on the left. Look. When you see too much shading, that means you fail to reject HO. So negative 0.72 and 2, 3, 4, 5. P-value. Which is bigger than alpha. Fail to reject HO. There is not enough evidence at the 5% level of significance to support the claim that the news poll was not correct. So actually, what we thought it's not correct. Can you conclude that the news poll was not correct? We couldn't. There's not enough evidence to support the claim that the percentage was less than 6%. So probably their claim is right. Probably it is 6% or higher. So this concludes the review for chapter 10. Probably a question you want to ask, just when you write the statement, when do we say the word to reject, just right here. You will only use the word reject, in your final statement only if the claim is in the null hypothesis. But if the claim is not in the null hypothesis, you will never use, the word reject. Again, if you reject HO, you say there is enough evidence. If you fail to reject HO, you say there is not enough evidence. I hope this review is helpful.